This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Fairyland of Science by Arabella Buckley. Read and recorded by Patricia Oakley. Lecture 3. The Aerial Ocean in Which We Live. Did you ever sit on the bank of a river in some quiet spot where the water was deep and clear, and watch the fishes swimming lazily along? When I was a child, this was one of my favorite occupations in the summertime on the banks of the Thames, and there was one question which often puzzled me greatly as I watched the minnows and the gudgeon gliding along through the water. Why should fishes live in something and be often buffeted about by the waves and currents, while I and others lived on top of the earth and not in anything? I do not remember ever asking anyone about this, and if I had, in those days people did not pay much attention to children's questions, and probably nobody would have told me what I now tell you, that we do live in something quite as real and often quite as rough and stormy as the water in which the fishes swim. The something in which we live is air, and the reason that we do not perceive it is that we are in it, and that it is a gas and invisible to us, while we are above the water in which the fishes live, and it is a liquid which our eyes can perceive. But let us suppose for a moment that a being, whose eyes were so made that he could see gases as we see liquids, was looking down from a distance upon our earth. He would see an ocean of air, or aerial ocean, all round the globe, with birds floating about in it, and people walking along the bottom, just as we see fish gliding along the bottom of a river. It is true, he would never see even the birds come near to the surface, for the highest flying bird, the condor, never soars more than 5 miles above the ground, and our atmosphere, as we shall see, is at least 100 miles high. So he would call us all deep air creatures, just as we talk of deep sea animals. And if we can imagine that he fished in this air ocean, and could pull one of us out of it into space, he would find that we should gasp and die, just as fishes do when pulled out of the water. He would also observe very curious things going on in our air ocean. He would see large streams and currents of air, which we call winds, and which would appear to him as ocean currents do to us, while near down to the earth he would see thick mists forming and then disappearing again, and these would be our clouds. From them he would see rain, hail, and snow falling to the earth, and from time to time bright flashes would shoot across the air ocean, which would be our lightning. Nay, even the brilliant rainbow, the northern aurora borealis, and the falling stars, which seem to us so high up in space, would be seen by him near to our earth, and all within the aerial ocean. But as we know of no such being living in space, who can tell us what takes place in our invisible air, and we cannot see it ourselves, we must try by experiments to see it with our imagination, though we cannot with our eyes. First, then, can we discover what air is? At one time it was thought that it was a simple gas, and could not be separated into more than one kind. But we are now going to make an experiment by which it has been shown that air is made of two gases mingled together, and that one of these gases, called oxygen, is used up when anything burns, while the other, nitrogen, is not used and only serves to dilute the minute atoms of oxygen. I have here a glass bell jar with a cork fixed tightly in the neck, and I place the jar over a pan of water, while on the water floats a plate with a small piece of phosphorus upon it. You will see that by putting the bell jar over the water, I have shut in a certain quantity of air, and my object now is to use up the oxygen out of this air and leave only nitrogen behind. To do this, I must light the piece of phosphorus, for you will remember it is in burning that oxygen is used up. I will take the cork out, light the phosphorus, and cork up the jar again. See, as the phosphorus burns, white fumes fill the jar. These fumes are phosphoric acid, which is a substance made of phosphorus and oxygen. Our fairy force, chemical attraction, has been at work here, joining the phosphorus and the oxygen of the air together. Now, phosphoric acid melts in water just as sugar does, and in a few minutes these fumes will disappear. They are beginning to melt already, and the water from the pan is rising up in the bell jar. Why is this? Consider for a moment what we have done. First, the jar was full of air, that is, of mixed oxygen and nitrogen. Then the phosphorus used up the oxygen, making white fumes. Afterwards, the water sucked up these fumes, and so, in the jar now, nitrogen is the only gas left, and the water has risen up to fill the rest of the space that was once taken up with oxygen. We can easily prove there is no oxygen now in the jar. I take out the cork and let a lighted taper down into the gas. If there were any oxygen, the taper would burn, but you see it goes out directly, proving that all the oxygen has been used up by the phosphorus. When this experiment is made very accurately, we find that for every pint of oxygen in the air, there are 4 pints of nitrogen, so that the active oxygen atoms are scattered about, floating in the sleepy, inactive nitrogen. It is these oxygen atoms which we use up when we breathe. If I had put a mouse under the bell jar instead of the phosphorus, the water would have risen just the same, because the mouse would have breathed in the oxygen and used it up in its body, joining it to carbon and making a bad gas, carbonic acid, which would also melt in the water, and when all the oxygen was used, the mouse would have died. Do you see now how foolish it is to live in rooms that are closely shut up, or to hide your head under the bedclothes when you sleep? You use up all the oxygen atoms, and there are none left for you to breathe. And besides this, you send out of your mouth bad fumes, though you cannot see them, and these, when you breathe them in again, poison you and make you ill. Perhaps you will say, if oxygen is so useful, why is not the air made entirely of it? But think for a moment. If there were such an immense quantity of oxygen, how fearfully fast everything would burn. Our bodies would soon rise above fever heat from the quantity of oxygen we should take in, and all the fires and lights would burn furiously. In fact, a flame once lighted could spread so rapidly that no power on earth could stop it, and everything would be destroyed. So the lazy nitrogen is very useful in keeping the oxygen atoms apart, and we have time, even when a fire is large and powerful, to put it out before it has drawn in more and more oxygen from the surrounding air. Often, if you can shut a fire into a closed space, as in a closely shut room, or the hold of a ship, it will go out, because it has used up all the oxygen in the air. So you see, We shall be right in picturing this invisible air all around us as a mixture of two gases,